Imagine a world where mayonnaise holds the key to unlocking limitless, clean energy. Intrigued? Keep watching to discover how this everyday condiment is revolutionizing nuclear fusion research. Inertial confinement fusion involves rapidly compressing and heating hydrogen-filled capsules to create plasma, a charged state of matter that can generate energy. However, this process faces a major hurdle: hydrodynamic instabilities in the plasma, which can drastically reduce energy yield. Banerjee and his team at Lehigh University, who are using Hellmann's real mayonnaise to simulate these extreme conditions without the need for high temperatures and pressures. Mayonnaise behaves like a solid but flows under pressure, making it an ideal analog for studying the Rayleigh-Taylor instability, a key issue in fusion research. Using a custom-built rotating wheel facility, Banerjee's team observed how mayonnaise transitions from an elastic phase to a stable plastic phase before becoming unstable. Understanding this transition is crucial for predicting and controlling instabilities in fusion capsules, potentially making fusion energy more attainable. Their latest research, published in Physical Review E, explores how material properties and perturbation geometry affect instability, offering new insights into delaying or suppressing it. Banerjee's work is a vital piece in the global effort to make fusion energy a reality. We're all working towards making inertial fusion cheaper and therefore attainable, he says. Stay tuned for more groundbreaking discoveries. Smash that like button, spread this video like a juicy gossip, and hit subscribe faster. We promise more mind-blowing content.